start talking about area of regular polygons, the first thing I wonder if we remember, do we remember what this word regular means? Anybody? Talked about it a while ago. It's been a minute. Dahlia?
Do they have like equal sides and equal angles?
Exactly. Regular means all of the sides are congruent and all of the angles are congruent. So for the next 2 days, we are going to be focusing on these shapes. They range from 3 sides triangle, 4 sides square, 5 sides pentagon, all the way up, however many sides you might have. Today, we're only going to talk about 3 of them. Tomorrow or Monday, we'll talk about a few more with some more sides. So for vocab, really the vocab isn't too crazy. We need to know about the center, which obviously is the center spot of your polygon. We need to know the radius. Specifically, the radius goes from the center to a vertex. So I'm going to draw a line from a center to a corner, and that is our radius. And then here's our new vocab word. Our new vocab word is this word apothem. Apothem is perpendicular, and it is the distance from the center to a side. So it goes from that center point straight down to the side. It forms a right angle, and also because of its property as a perpendicular bisector, it's going to make both of these pieces congruent. So both of those pieces of the side, basically, it's the line that goes from the center of my polygon straight down to the middle of one of my sides at a right angle. Any questions on that? Here's our new formula. To find the area of any regular polygon, again, it is important that it is a regular polygon. We can't use this on any triangle we want. It has to be a regular triangle. The area of a regular polygon is 1/2 the product of the apothem and the perimeter. 1/2 A times P, where A stands for apothem and P stands for the perimeter of my shape. So if I take a look here, my apothem is going to go from the center down to the middle of the side, and the perimeter is the entire way around this shape. Questions on that? Where does this formula come from? Well, if we think about a shape, let's say I look at a 5-sided shape. This is a pentagon. I want to think, how many triangles can I split this up to? A lot of geometry is triangles, right? So I can split this into 1, 2, 3, 4, 5 equal triangles. Yes, we see that? How do I find the area of one of these triangles? I'm going to call this the base times the height. So 1/2 base times height, right? And now, what if I need to find the entire area of this shape? Well, I'm just going to do that for all 5 of the triangles that I've now drawn. Right, that's 5 of them. I'm going to use a little bit of algebra magic to take out a GCF of 1/2 height, which leaves me with base plus base plus base plus base plus base. Here's my height. Here's all my bases. Oops, I wanted to do that in purple. Here's all my bases. And now if I think about base plus base plus base plus base plus base, that's the same thing as saying perimeter. So this is 1/2 height times perimeter. And then we just use that fancy word for height. We change that to 1/2 apothem times perimeter. That's where that formula is coming from. So if you forget this formula, this one right here, if you forget this ever, just know you can split this up into triangles. You can find your area of each triangle and then multiply it by however many triangles you have. Good? Any questions on that? That's not something you need to memorize, but you should know at least this formula, 1/2 apothem times perimeter. So let's practice. I'm going to draw in apothms and radii that are going to get me right triangles. So I'm going to take a look at these three shapes. These are the three shapes we're going to focus on today. And I'm going to draw a radius from the center to a corner. Okay, everybody got that radius from the center to the corner? And then I'm going to draw an apothegm. The apothegm goes from the center straight down and makes a right angle. Specifically today, we are going to look at these three shapes because those little triangles, those reference triangles that we're looking at, give us some special properties. So these three shapes in particular, we have an equilateral triangle, a regular quadrilateral is called a square, and then we have a regular hexagon. These are the only three we're going to focus on today. Let's talk about what those special properties are. Again, they have the radii and an apothegm drawn for me. So I'm going to highlight these in the correct colors because I like them to be color-coded. So there's my radius. There's my apothegm. Let's talk about the angles here. If I look at angle 1, because we know that this is regular, all three of those little sections should be the same. So the measure of angle 1, if we think about going in a full circle, is 360 divided into 3 pieces. So that's 120 degrees for angle 1. That also means this is 120 and the bottom is 120. Angle 2 is what's created when I draw in that apothegm. Basically, when I draw in an apothegm, I'm splitting that central angle exactly down the middle. So I'm going to take that angle, 120, and I'm going to divide it by 2 to tell me that this angle 2 is 60 degrees. Everybody still with me? Then I'm going to look at that triangle, that little reference triangle. I have a 60-degree angle. I have a 90-degree angle, which means this little leftover angle in the corner here is what? Anybody? Do that little math there? Should be 30 degrees. Those values look familiar, hopefully. This is a 30, 60, 90 reference triangle in here. So this little reference triangle is 30, 60, 90. Isn't that nice? Okay, let's look at the square. We're going to do the same thing. Remember, these radii of my square are splitting this square into 4 equal pieces. So the measure of angle 1, I'm going to take the full circle and divide it into 4 pieces. That gives me 90 degrees. My apothegm takes that angle and divides it in half. It cuts it literally right down the middle. So angle 2 is 90 divided by 2, aka 45 degrees. And then I'm going to think about what's left over in this triangle. If I have 45, 90, the last remaining angle should also be 45 degrees, which makes this a 45, 45, 90 triangle. Everybody good with that? Let's look at the last one. Again, these radii, splitting this shape into 6 equal parts. The measure of the first angle, angle 1, is 360 divided by 6 pieces, or 60 degrees. That apothegm is going to take that 60-degree angle and split it in 2. So 60 divided by 2 is 30. And then what's left over in this triangle, if I have 60, 90, the last one, if I have 30, this is 30, 90, and then the last one must be 60 degrees. So another 30, 60, 90 triangle. Questions on that? So that means that all three of the shapes we're going to focus on today make special right triangles. So let's take a look on the next page. At the top of our page, I'm going to rewrite my special right triangle rules just really quickly so that we have them in front of us as we're working through this. Here's my first triangle. This is a 45, 45, 90 triangle. Remember that my legs are the same in a 45, 45, 90, and my hypotenuse is the leg times radical 2. And then for a 30, 60, 90, the short leg is x, the long leg is x radical 3, and the hypotenuse is 2 times the short leg. If you do not know your special right triangles at this point, oh boy, you really got to learn your special right triangles. Okay, so what's nice about these three special shapes is that those angles that we just found above here, those are never going to change. They're always going to be the same. So you can memorize these things. However, for the sake of we haven't done any of these yet, I'm going to show you how we find them once more. Remember that one full section is 360 divided by the number of pieces, so that's 120. And then my apothem cuts that number in half. So this top angle here is 60, which makes this angle down here 30. Everybody good with that? Everybody see where those angles just came from? Okay, so now the apothem in this shape is this 4 right here. Everybody sees that? Apothem is 4. In my special right triangle, that's the short leg of my 30, 60, 90. So to find the long leg, because the next thing that I need for my formula is the perimeter. So I need to figure out what this guy is right here. I'm going to take my short leg and multiply it by radical 3. That apothem is literally cutting this base in half. So the other half of my base is also 4 radical 3, which makes one full base of this triangle 4 radical 3 plus 4 radical 3, or a total of 8 radical 3. Now that still is not my perimeter. My perimeter is I take the length of one base, and I'm going to multiply it by however many sides I have. In a triangle, that's 3 sides. So this is 24 radical 3 as my perimeter. I strongly suggest you leave this in exact values unless you can store this value in your calculator, because I don't want you to round until the very last step. So keep this as 24 radical 3 as long as possible. Everybody good with how I got those two numbers? 4 and 24 radical 3. The last piece then is to plug this into your area formula, which is 1/2 times the apothem times the perimeter. And this you can plug right into your calculator all in one step if you would like to. 1/2 times 4 times 24 radical 3. And here we can round. I got 83.1 units squared. Any questions on that? Okay. So now when I go to another triangle, my shape hasn't changed. That means these angles haven't changed either. This is still a 30, 60, 90, where the 60 is up at the top and the 30 is down in the corner. This time I know my hypotenuse is 12, so I'm going to have to find the short leg first, which is our apothem. Our short leg is 12 divided by 2, or 6. And then my base here, or 1/2 of my base, is I take that short leg, I'm going to multiply it by radical 3, 6 radical 3. That makes one full base of this shape 12 radical 3. And the perimeter is 12 radical 3 times 3 sides, or 36 radical 3. Everybody cool with that? Okay. Plug it all in together. Area equals 1/2 times 6 times 36 radical 3 which gives me, what did I write? 187.1 units squared. Any questions so far? We're going to move on to a different shape. Squares can use this formula. You can successfully use the 1/2 apothem times perimeter formula for a square. However, do we know a more simple formula for a square? What's the area of a square formula? Casper. I think S squared is much more efficient than 1/2 apothem times perimeter. So I'm going to say if you have a square and you have some information like this where you can just, instead of finding the apothem, find one of the sides, do that. Don't do more work than you have to do. Can you still find the correct answer the long way? Sure. Do whatever you got to do. But I'm going to save you some time here. In this square, if I need to know, I know that this splits into 4 different sections. So 360 divided by 4 is 90. I'm going to divide that in 2 with my apothem, which is 45. So this is a 45, 45, 90 triangle, which means I don't need to find the apothem. The apothem is not relevant in my square formula. But this guy, that other leg, is 20 radical 2 divided by radical 2, which is 20. One whole side is 40. So the area of this square is 40 squared, or 1600. See how much easier that is? We like that, or do we hate that? Okay, ready? Next. No shortcuts for this one, unfortunately. Here's a hexagon. I gotta figure out where my angles go first. I'm going to split this into 6 pieces. So 360 divided by 6, because it's a hexagon, gives me that each angle is 60. The apothem takes that angle and divides it in half. So that means this angle up here is 30 degrees, which means this one down here must be 60 degrees. That means the apothem that they've given me is the long leg. Okay, the short leg is going to be this base that I'm trying to find. Oops, let's change colors. Let's write in the apothem. The apothem is 3 radical 3, and we're trying to find this short leg. So to go from the long leg to the short leg, I'm going to divide by radical 3 to get that this is 3. 1 full base is 6, and the perimeter is 6 times 6. Or 36. Plug it all in. I'm not doing anything crazy here, right? 3 radical 3 times 36. And the number that I'm going to get out is like 93.5 units squared. Okay, one more. Apothem, perimeter. Remember, we use the same angles because I just did a hexagon. I don't need to do it again. Hypotenuse is 16 radical 3. What's that short leg down at the bottom in purple? If the hypotenuse is 16 radical 3, Caitlin? Yep, we're going to divide that in half to get the short leg, so 8 radical 3. Which makes 1 full base, 16 radical 3. Oops. The perimeter of this guy is going to be 16 radical 3 times however many sides I have. I have 6 sides. So 16 radical 3 times 6 is 96 radical 3. And then the apothem. The apothem is the long leg. So I'm going to take the short leg, 8 radical 3. And I'm going to multiply it by radical 3. Radical 3 times radical 3 is 3. So this is 24 for my apothem. Oops. Let's zoom out. And then my area. 1/2 apothem times perimeter Plug it all into your calculator. I got a big number, 1,995.3 units squared. Any questions on that? Make sure you filled in your little blue sheet. You should be able to fill in number 6 now that we know that formula.